Okay, first things first. I'm gonna get into developer tests, but I haven't installed anything but Chrome on the new Mac Studio. This is the one with the M1 Ultra chip. But before we do all that, there's been a lot of talk about how much power consumption this thing's gonna take, and the fact that it takes very little amount of power. That's good. How does that translate into performance? How does it translate into day-to-day use? We're gonna find all this out on this channel, so if you're not subscribed yet, consider subscribing. For today, I wanna take the vitals of this machine. If you came to the live stream the other day, thanks for doing that. We did some of this, but we didn't quite get to everything yet. Let me introduce you to a new little friend, not so little. This is the Alienware something or other. I should know the names of these things. Not a problem, I'll just read the box. It's the Alienware Aurora Core i9 12900KF processor, Intel, 32 gigs of RAM, 1 terabyte SSD, and NVIDIA GeForce RTX 3080 Ti with 12 gigabytes on board. And it's got high performance cooling. Okay, let me tell you, that was not fun to drag around. We're gonna spin this thing up. We're gonna compare the power draw on both of these machines. I'm gonna max out the CPUs using maybe not the most conventional techniques, but since this is a developer focused channel, we're gonna use some code to do that. We'll see how much noise these machines will generate, and I'll try to get a temperature readout, although I don't know if I'll be able to get inside of this thing to do that. We'll find out. This might be the last time you hear me in such a quiet environment too. It might get loud in here. So let's turn this one on, press the Alien to do that. And it might get a little hot in here, folks, because, well, it's a small room and I got the door closed. All right, I've logged in to both of these machines. Now they're just sitting there idling, and here is the power draw. We got 42 on the Alienware machine, 42 watts, and 11.1, yeah, around 10.7, 11.1 on the Mac Studio. Now, as far as noise levels go, it's kind of hard to tell at this point because both machines are on, but I've got this microphone. I'm gonna place it behind the Mac Studio right now. Not that behind it really matters because, well, it's facing away from you, so I'm not gonna hear that noise, which is one of the benefits of the Mac Studio. The noise is kind of away from you. You can max out the fans using software like I did in that short, but that's not how it operates under normal circumstances. So I can barely hear it because the Alienware machine is making all the noise. Now, there's some kind of weird buzz or hum coming from the Alienware machine, and I'd imagine that you are probably not gonna be sitting next to it like this. It's probably gonna be further away from you. Nonetheless, there you go. So that's the actual noise while sitting and idling. Let's see if I can get anything in the reading. So 40 decibels pointing at the Mac Studio, 43 pointing at the Alienware machine. Not a big difference. Now I've noticed that the Alienware machine has spikes. Once in a while, the wattage usage just jumps up to 100 or more and then comes back down. That does not happen with the idling Mac Studio, not that I've seen so far. I'm gonna show the screens of each one of these machines in the video. Let's start over here on the Alienware machine. Oh gee, I hope you can hear me. I'm gonna open up Task Manager. There's my CPU readout, and on the performance tab we can see what's going on with the CPUs. If I right click here and go to change graph to logical processors, whoa, look at that, 24, really? That doesn't make sense. Yeah, I guess there is 24 processors, but there's 16 cores, so why are there 24 processors? Huh? I'm thinking that 12 of these are high performance and 4 of them are efficiency, and that's why the 24 is actually a multiple of the 12, which are performance cores, and therefore they're gonna be using the hyper-threading model. If I'm wrong, just leave me a comment down below, please. So we're gonna get into Chrome, and I'm gonna go to a site. Google is pretty good, and let's go press F12 to open up developer tools. And on the console, I'm gonna write a for loop. Just a little bit of a zoom for you there. That's what the for loop looks like. If I press enter there, it's gonna execute the for loop. Of course, this is JavaScript running in the browser. It's basically an infinite loop that's going to use up 100% of one of the cores. And you can see the spikes coming up right now. Now, the overall CPU utilization is reported here on an Intel machine based on the entire available scale, not like it is on the Mac. So that's what we got. Now, just based on running that one for loop, take a look at the power consumption. 108. We've more than doubled the power consumption just from that one for loop. So that's 108, 106. Let's check this on the Mac. So on the Mac, I'm gonna open up Activity Monitor, which pretty much does the same thing, except the way it reports CPUs is a little bit different. Let's pop open Google and F12 for developer tools. Let's go over to the console, and I'm gonna do the same exact kind of for loop here. Let's go. All right, let's take a look at where that is in the Activity Monitor. And you can see it right there, taking up 100% of one core. So the way Macs report this is that they report 100% if it's using one full core. And if we drill down into that CPU load right here, you can see all 20 cores there, and the first two are efficiency, and also core 11 and core 12 are efficiency, but the rest are performance cores. And you'll see that we got a spike on some of these cores. It's being shared between different cores. That job is being split up, but this gives us a nice little visual representation of that. Now, as far as power usage, have a look. 18 watts on the Mac, 108 on that Intel machine. But we're not gonna stop there, are we? No, we're gonna max this thing out. So I'm getting 80 degrees Celsius from measuring or trying to measure, and anywhere I measure, it's about the same. Even if I point directly at the processor, maybe the light is bouncing off of the case, so I'm not sure. It's reporting 81 there, so not that much. And noise level hasn't really gone up in this room either that much. So let's keep going. I'm gonna open up another tab and do the same thing here. Another for loop. And another one. By the way, you might be wondering why I'm going to Google first. I tried doing this just in the browser, and without having a website open, it actually terminates my forever loop. So that's why I'm going to Google first. Okay, I got 8 of them running on the Windows machine. And what do we got? 232 watts being used, up to 234 even. Let's have a look at the task manager. Whoa, crazy graph. But look at that, we're only at 51% utilization. I think we got some more headroom. The system is still responsive. I can still move windows around pretty nicely. And the sound level hasn't gone up much either. All right, let's do the Mac. So we've got 8 processes and all of them are using 99%. We're not throttling, which is good. And I think we're using half of the resources. So we still got some headroom on this one too. Now, this is the funny part right here. 232 watts being consumed by the Intel machine and 36 watts being consumed by the Mac Studio. Just for reference, I'm gonna record the noise. There's the Mac, here's the Windows machine. Okay, let's keep going. I'm up to 12 now. 12 tabs running 12 infinite loops at 75% utilization. Oh, I'm hearing something. Okay, I'm up to 16 tabs. Let's have a look at the task manager. We're at 95% utilization. That CPU chart looks crazy, but the machine is remaining pretty calm. Temperature is measuring at 82 degrees. I am hearing slightly more noise coming from the Alienware machine, but not significantly more noise. So it's about the same amount as before. Power consumption is about the same as before as well. So that extra work that we've added didn't amount to much when it comes to power consumption. Go back to the Mac, do some more work here. Work. This is not real work. I don't know what this is. It is hot in here, so I feel like I'm working. I feel like I'm doing physical work. Maybe I can consider this my workout for the day. Okay, I've done the same thing here. 16 tabs open. I believe I can open 4 more to get maximum utilization on the Mac. It has 20 cores after all, although those 4 efficiency cores, not 100% sure that they're being used to do this kind of pretty intense task. So right now, it looks like every core is being used, every performance core is being used at 100%. 99.6. The machine is still very responsive. It's still working quite well. We are up to 53 watts being used by this machine. And the top of it is nice and cool. I think I might have to measure the temperature from the bottom to see what that's like. So let's flip this over. And it's measuring 81 degrees. So about the same as the measurement I'm getting from the Intel box. But I don't think that that's very accurate unless I open the box up and get inside of it. Now with the MacBooks, because they're so thin, the physical temperature measurements are going to be better because the processor is so close to the chassis. Now here, the box is very large and bulky and there's heat sinks in there, so it's gonna be spreading out that heat quite well. Now if we take a look at TG Pro, which is the software that tells me the temperature of the Mac, the internal CPU temperature, right over here, you'll see that all the cores are pretty much registering a nice calm day of 50 to 55 degrees, and the fan hasn't really spun up more than it does just sitting there idling. I'm gonna add 4 more tabs here because there's 20 cores. I've added 4 more tabs. And now, look at this. We're down to about 80% utilization on each CPU core, down to 79 even. And that's happening because each one of these processes is taking up less of the CPU because there's more tabs open, less CPU cores available per tab. So after you get to, 20, I guess. Was it 20? I think it was 20. So after we get to 20, at that point, we start to spread out that work. But if you take a look at the history chart, you can see that all the performance cores are fully utilized and the efficiency cores are also helping out quite a bit at this point. But the temperature is remaining at 56 degrees. So the cooling system on this thing is incredible. And the RPM is not really spinning. The fan is staying pretty calm, which is pretty amazing. Wattage, the power consumption is at 53 watts and not really going over that. So now this is a pretty synthetic test. I'd like to test it out in the real world. We're gonna do some builds as well to see how that does. Let's get back to this Windows machine too. So at this point, I've added 4 more, which did push the CPU all the way to 100 utilization. That CPU is being pegged right now, but we're seeing that the power consumption has stabilized at around 225 watts, and I don't hear the noise level going up too much. So obviously we're dealing with pretty powerful desktop machines here, both of these, where it can really handle these kinds of loads. Now, none of this is pushing the GPU, by the way. So that's gonna be a whole different story. I'm not gonna do that today, but once we start pushing the GPU, we might hear a different noise level in this room. So there you go, folks. Some initial vitals on the Mac Studio, as well as this Core i9 Alienware machine. Subscribe if you wanna see some more developer tests and benchmarks on this channel, and I'll see you next time.